My name is Dr. P.C. Patel, Chief Soil Health Specialist, Mati Mati Agromart Private Limited, Bhavnagar, Gujarat. At present, I am residing at Anand, Gujarat, India. So the topic is soil properties which have an influence on soil fertility. You know that there are three properties: physical properties, chemical properties, and biological properties of soil which influence the soil fertility, and the crop productivity depend upon the soil fertility. Farmers, their advisors, and any growers need to know the soil property which have an influence on soil fertility, some of which include soil texture, structure, bulk density, consistent infiltration, cation exchange capacity, available water holding capacity, and pH reaction. So important soil properties: soil color, texture, structure, consistence, bulk density, infiltration, available water holding capacity. Soil color. So it is a useful tool for providing information about other soil properties: organic matter content, soil minerals, and seasonal high water table. So when you will find a dark black color, then that soil have high soil fertility. And here you can see low fertility. So I told that black brown color have higher fertility as compared to yellow, red, white, light. So on the gray, so that soil have a lower fertility as compared to the black brown fertility. So soil color also influence and which can indicate the soil fertility. Soil texture. Minerals in the soil come in many sizes and are generally classified as coarse particles, anything in the soil larger than 2 millimeter, fine particle less than 2 millimeter, sand 2.0 to 0.05 mm, silt 0.05 to 0.002 mm, and clay less than 0.002 mm. So clay is the smallest particle, and we cannot see the naked eyes, but for that electron microscope is required. Whereas sand is a larger particle and we can see with our naked eyes. So the soil texture means the relative proportion of sand, silt, and clay particle in a mass of soil. So texture class, soil texture is the percentage of sand and clay in the soil. So sandy soil, 70% sand, silty soil, 80% silt or more, clay soil, 40% clay or more, loam soil, perfect mix of sand, silt, and clay, most desirable for growing crop, means 33%. But it is not possible, you will find at some places. And the soil texture classification has been made by United States Department of Agriculture. So it is a texture triangle. So we can use by soil scientists to the basic texture classes. Field soil scientists frequently estimate the texture by feel using their hand. So by feeling with the hand, we can know that it is a sandy soil, silty soil, or clay soil or black soil. For more exact measurement, there are laboratory techniques that can determine the exact amount of sand, silt, and clay. So on the basis of this % sand, % clay, and % silt, the soils of the India or the world has been classified on 12 classes. So there are 12 classes of the soil has been given. So you know that soil separate, there are 3 soil separate: clay, silt, and sand. So clay soil separate is the active one as compared to the sand is a inert matter. So you can see that aeration is poor in clay soil. So in clay soil, whereas in sandy soil, aeration is very good or excellent. Bulk density, clay particle low, clay excess, sand particle high bulk density. Internal drainage poor, good, and excellent in sandy. Temperature warm slowly, warm moderately, warm quickly. So you know that sand warm quickly and cold also quickly. Then tillage, in when the soil is dominant in clay, more than 45%, then tillage operation is very difficult. Whereas in sandy soil, the tillage operation is very easy. Whereas in silty soil, it is moderate one. Then texture. Soil containing large amount of sand exhibit little plasticity and cannot retain large amount of water or nutrients. They have large voids between the particle and can readily transport. So sandy soil have low water holding capacity and it is it is not fertile soil. So it is a poor in soil fertility. The percentage of silt are intermediate between sand and clay. Silty soil can retain large amount of water but tend to have moderately slope permeability. Soil high in silt can present problem for engineering since they will shift under stress and slide and flow when wet. Texture. Clay exert a great influence on soil chemical and physical properties. I told that clay is an active particle. Clay particles are chemically active and the proportion of clay-sized particles greatly influences soil physical properties, including aggregation, porosity, water movement and storage, aeration, and workability of the soil. So I told that clay, the soil separate size is less than 0.002 mm. So the total pore space or total surface area of the clay soil is greater. So there will be more absorption of the nutrient and more absorption of the water. Whereas in sandy soil, the particle of the sand is greater, 2 mm. So the surface area is low. So there will be less absorption of the nutrients and less absorption of the water. So we have to apply irrigation frequently in sandy soil. And for improvement of this sandy soil, as the soil is poor, we have to add more organic matter for improving the soil fertility. Soil structure. Soil structure is the arrangement of the particle in the soil. Structure affects aeration, water movement, heat transfer, and root growth. Granular is ideal for agriculture, allows for maximum pore space. So granular structure is very important and it is ideal for agriculture and it allows for maximum pore space. So better aeration. So soil structures, I told that granular is the best structure. Then platy structure, blocky structure, prismatic structure, single grain structure, columnar structure, and massive structure. So there are 7 soil structure. Then consistence. The degree and kind of cohesion and adhesion that soil exhibit and or the resistance of soil to deformation or rupture under applied stress. Field evaluation of consistence usually include rupture resistance, stickiness, and plasticity. Rupture resistance is a measure of the soil ability to withstand applied stress. For this test, moist soil is normally used. A naturally occurring soil aggregate is placed between the thumb and index of finger. So you have to put this soil aggregate and you can find it. So pressure is slowly applied to estimate the amount of force that is required to rupture a soil aggregate. So by feeling, we can know that the soil is sandy soil, silty soil, or clay soil. Stickiness. So stickiness is the capacity of the soil to adhere to other object. Stickiness is estimated at the moisture content that displays the greatest adherence when processed between the thumb and forefinger. This normally occurs when the soil is quite wet. Then plasticity. Plasticity is the degree to which a reworked soil can be permanently deformed without rupturing. Plasticity is evaluated by forming a wire of soil that is 4 centimeters long. Then shrink swell potential. Shrink swell potential is the measurement of the amount of volume change that can occur when a soil wets and dries. So we have to apply the water and we have to keep it dry. So most of this volume change is due to the clay fraction of the soil. So clay swell when wet. So when we have the clay soil, then when we wet it, it will be swell. When it is shrink, when dry, so here you can see it is shrink. Soil high in 2:1 clay such as Montmorillonite tend to have high shrink swell potential. Soil high in 1:1 clay such as kaolinite tend to have low shrink swell potential. So you remember that in Montmorillonite type of clay mineral, soil have a more clay, dominant clay particle. Whereas in kaolinite, sand particle is dominant. So the Montmorillonite clay mineral have higher cation exchange capacity, whereas kaolinite has only 3 to 15 cation exchange capacity. So Montmorillonite clay mineral soil have more fertile as compared to kaolinite, that is a sandy soil. A soil with a high shrink swell potential can cause severe problem. Shrinkage and swelling can buckle roads, crack building, you can say here, crack in building, then road is also crack. Then crack building foundation and walls and even damage and plant roots. It also damage the plant root. Because when you sow the crop, when you put the seed in a clay soil, then what happens? When the moisture, then there is no problem, but when the soil is dry, then there will be crack formation and there will be remove the contact between soil and seed. So there will be effect on the seed germination. Then bulk density. Bulk density is the mass of dry soil per unit volume, including the airspace. Bulk density has a major effect on the movement of air and water in the soil. Soil with high bulk density are often compacted. So lower bulk density, lower weight, more pore space. So lower bulk density is desirable for the agriculture point of view. Here higher bulk density, higher weight, less pore space. So here when you grow the crops, then there will be poor aeration, but when you grow the crop, when you have the lower bulk density, then there will be more pore space, so better aeration. So by applying the organic matter in soil, you can lower down the bulk density. So it is advantageous to increase the aeration. And when you are adding the organic matter, it can improve the soil fertility. Then soil compaction, restrict root depth, which reduce the uptake of water and nutrient by plant. So when there is a compaction of the soil, then there will be poor aeration and lesser uptake of the water. So here you can see that here the soil is compaction, so there is a poor root formation, whereas it is a no compaction soil, loose soil. So here you can see the growth of the roots and there will be better growth of the plant. Then bulk density. Compaction also decrease infiltration. When there is soil is compact, then there will be decrease infiltration rate and thereby increasing runoff. So water will not absorb in the soil. So there will be runoff of the water and hazard of water erosion. So there will be erosion. So when the soil is loose, then there will be less chances of the erosion, because whatever the water you receive, that was absorbed, because there will be better infiltration rate, whereas in compact soil, the infiltration rate decreasing and there will be increasing runoff and soil has been lost. So there will be more water erosion. Infiltration. Infiltration is the downward entry of the water into the immediate surface of the soil and is influenced by texture, structure, bulk density, and the type of connectivity of macropore. Soil with a high infiltration rate are resistant to erosion because there is little runoff. So I told that when a soil have a higher infiltration rate, then there will be less erosion. So in sandy soil, there will be better, higher infiltration rate. So there will be less erosion in sandy soil. But in black soil, the infiltration rate is low. Available water holding capacity. The capacity of the soil to hold water available for use by most plants. So it is commonly defined as the difference between fill capacity, between the amount of soil water at fill capacity and the amount of water at the permanent wilting point. So it is a difference between the amount of water at fill capacity and the amount of permanent wilting point. So that water is available. So it is commonly defined as the differences between the amount of soil water at fill capacity and the amount of water at permanent wilting point. So that water is available to the plant and that water is not available, unavailable to water. Then reaction. It is also known as soil pH. So reaction is the measure of the acidity or alkalinity of the soil. So acidity or alkalinity is determined by the amount of hydrogen and hydroxyl ion in the soil. When hydrogen ion outnumber hydroxyl ion, the soil is acidic. When the soil pH is less than 7, then it is called acidic soil. When your soil is increasing, the soil pH greater than 7, then it is a alkaline soil. So you know that plant take the nutrient at the soil pH 6.5 to 7.5. Majority of the nutrient you can see nitrogen, phosphorus, potassium, sulfur and calcium, magnesium are more available at 6.5 to 7.5. Means very slightly acidic, very slightly alkaline. So at that pH, majority of the nutrients are available. But the micronutrient iron, manganese, boron, copper and zinc, except molybdenums, are more available at 5.0 to 6.5 soil pH. But the exception case, molybdenum is more available at 7 pH to 8.59 pH also. So the nutrient availability depends upon the soil pH. It influences the ability of the nutrient. Suppose there is a soil pH is 9, then the nutrients are present in soil, nitrogen, phosphorus, sulfur, micronutrient, but it is not available to the soil due to constraint of the soil pH, high soil pH. So that soil is degraded, problematic soil, and the productivity of the problematic soil means saline alkaline soil is low as compared to normal soil. It is also true for the acidic soil. In acidic soil, the major secondary and micronutrients are present in the soil, but it is not available to the plant because the soil pH is lower than 5, 6. So it is not available there. So the productivity of the saline alkaline soil or acidic soil is poor. The fertility is there, but the productivity of problematic soil is low due to constraint of higher soil pH in saline alkaline soil and lower soil pH in acidic soil. So for improving the saline alkaline soil, we should have to add gypsum and add more organic matter in soil and also made provision of the drainage. So whatever the salt accumulated, that has been drained from the field. Whereas in acidic soil, we should have to add lime because here the soil pH is low. So we have to increase the soil pH. Whereas in alkaline soil, we have to decrease the soil pH 8.5 to 6.5, 7.5 and so. So for that, we have to add more organic fertilizers, organic manures, and should have also used the acid forming fertilizer like ammonium sulfate, urea, ammonium nitrate, etc. Then cation exchange capacity. Cation exchange capacity is a measure of the ability of a soil to hold and exchange cations. It is one of the most important chemical properties in soil, and it is usually closely related to soil fertility. So soil fertility dependent upon cation exchange capacity. So I told that montmorillonite clay mineral have higher cation exchange capacity, 85 to 100 cation exchange capacity, whereas the cation exchange capacity of the kaolinite and eclite is lower than the montmorillonite. Though soil is poor or medium in fertility, a few of the plant nutrient cation that are part of the cation exchange capacity include calcium, magnesium, potassium, and ammonium. So cation exchange capacity is helpful, goes for determining soil fertility. So suppose we have soil and you have to find out the cation exchange capacity, and on the basis of the cation exchange capacity, you can know that the soil is poor soil or medium fertile or rich in soil fertility. Negative charged clay and or humus particle hold and store positively charged cations. So you know that the clay and humus have a negative charge and they hold the positive charge like calcium, magnesium, potassium, and so on. Then plant root exchange hydrogen cations for essential nutrient it cannot produce for itself. So you know that how the plant will take the nutrient. So plant root execute the hydrogen cations and the calcium, magnesium, potassium from the soil solution it exchange, and thereby plant will take the nutrient through the soil solution, and that nutrient translocated from the plant parts like branches, then flower parts, root, etc. So today the end of my topic. So if you have liked my video, then I request you to please subscribe. Thank you very much.